All right, we have another question. Same year 2017 GCE. Yes, physics. And the question reads: an automobile or mobile of mass 2000 kg started from rest position and increased its speed uniformly to 9 meters per second in 30 seconds. It maintained this speed for another 500 seconds. All right, then the first question is: sketch the speed time graph of the automobile for the journey described. All right, so what you need to do is first is to draw the x and the y axis. All right, so if they say the car starts from rest, so this is the speed time graph. Speed time graph. Okay, so this is the speed time graph. All right, so they're saying a car starts from rest. Rest, it means initial position, which is here 0. Okay, and it increased. Okay, and increased its speed uniformly. So when the speed is increasing uniformly, it means that is acceleration. So make sure you use the ruler. I'm using a free hand because the other hand is holding the camera. So this is supposed to be straight. You use your ruler. Okay, up to where you see, okay, it's fine here. They're saying for it reaches the speed of 9 meters per second. So here you can just write. So by the way, this is time in seconds. This is speed in meters per second. So let's say this height is 9. Okay, so let's write 9 here. Okay, and then here, I mean, is it 9 from the question? Yes. Then for 30 seconds, so write 30 here. We know that time is measured in seconds this side. So the other statement is that it maintained this speed for another 500. So we can't just maintaining speed. It means you have a flat graph here. It was moving at 9 meters per second. So we can't just write 500. We add 500 plus 30 seconds. So this is the flat. So we can just say 500 plus 30, which is 530 here, because we are told here that it maintained this speed for another 500 seconds. All right, so 530. Another question. Anyway, that's all. So this is the graph. Okay, so this is the graph. We've sketched it, and it's how many marks? It's 3 marks. All right, it's 3 marks. The next question is calculate the uniform acceleration of the automobile, which is 2 marks. So this is question A, and this is question B. Acceleration is equal to final velocity minus initial velocity over time taken. If you analyze data here, do we have acceleration? No. It's the one we're asked to find. Do we have final velocity? Yes, it's 9 meters per second. Do we have initial velocity? Yes, it's 0 meters per second, the initial point here. Do we have time taken? Yes, from 0 to 30 is 30 seconds. Then you substitute in the equation and the formula. Acceleration is equal to V, which is 9 meters per second minus 0 meters per second over 30. Here, 30 seconds. So acceleration is equal to, when you subtract here, you have 9 over 9 meters per second over 30. Okay, acceleration is equal to, of 30 seconds, so 30 into 9, it can't, so it's 0 point, and then this becomes 90. 30 into 90 is 3 times, so it's 0 0.3 meters per second squared. That's our answer, 0 0.3 meters per second squared. The next question is, how much force was required to produce this acceleration? So this is question C. How much force was required to produce this acceleration? So this one is, force is equal to mass times acceleration. So force is equal to mass. We have in the, remember in the first statement there, we are given the mass as 200 kg. So here we're going to substitute here 2000 kg, not 200. Acceleration is 0.3, we've found here, 0.3 meters per second squared. So when you calculate 2000 multiplied by 0.3, we are going to have 600 newtons. Remember, force is measured in newtons, so 600 newtons. All right, question E at D. Calculate the distance covered by the automobile when it was moving at a constant speed. So when it was moving at constant speed, it formed this shape, which is a rectangle from here up to here. So to calculate D, to calculate the distance covered, we are going to use the shape formed here, which is distance, the area of the shape, which is LB, L times B. Okay, length, we can get this one as our length, or LH is fine. We can get this one as our height or our breadth. So it will be length from 30 to 530. The difference is 500. So 530 minus 30 is 500. So here we substitute with 500 multiplied by, this is, so you can just write, let me just write this with a pencil. You write with a pencil for you not to get confused. So this is our L, then this is our B. So from here up to here is there 500, from here up to here is 9. So it will be times 9 here. 5 times 9 is 45, and you come up with the zeros here. And remember, distance is measured in meters. So it's 4,500 meters. Last question. What was the average speed for the automobile for the journey? For the journey here, it means that is for the whole journey. So to calculate the average speed, remember, this is question E. Remember that average speed is equal to distance covered over total time taken. Now, do we know the distance, total distance covered? No. This 4,500 is the distance covered here, not for the whole journey. So let's find the distance covered in the first 30 seconds. Then we'll add it to the distance we found here, so that we come up with the total distance. All right. So the distance covered first there, since this one is a right angle triangle, we are going to use half BH. So half BH, this is half, B is 30 here, H is 9, half of 30 is 15. 15 times 9. So half of 30, 15. 15 times 9 is 15 times 9 is simply 135. 135. So 135 plus the distance, which is here, 4,500. We're going to have, so 135 plus 4,500. The answer is 4,635. 35. So this is the one you're going to substitute here. 4,635. The total time taken is 530. So 4,635 divided by 530, we are getting 8.74, 8.75, round it off, 8.75 meters per second. And this was the average speed for the journey. So that's how you answer this question. First you sketch, then you go through, you answer other questions. So it is as simple as this.